today our focus is free response questions. So last chapter when we did free response questions, they were very specific. It was like IVT, and you had to say these exact 5 phrases in order to do it. And we did continuity, and we said in order to do continuity, we had to do these things. That's not necessarily true with this chapter. Okay, this chapter is more starting to apply it, and there's a lot of different concepts. Okay, one of the things we got to be good with is motion. Okay, a reminder that on the test on Friday, there are 3 questions that are calculator. Okay, 3 of the 9 multiple choice are calculator. The other 6 are not. And so you have to make sure that you can handle using your calculator and be able to do what you need to do. It says a particle moves along the x-axis so that its velocity is given by this equation right here. At the time t equals 0, the initial position of the particle is 7. This phrase right here, the initial particle, that doesn't really apply to us yet. Okay, that is something we will use a lot when we get into January, but we're not ready for it yet. So for right now, that just doesn't really do anything. Cool, that's velocity. They want to find acceleration. What am I going to do with velocity to find acceleration? Find the derivative. So I get to use my calculator, so I'm going to use my calculator. Okay, it's real easy. If you get to use your calculator, make sure you're using it. V of t equals, it's a fraction, so alpha f1, x to the 6th minus 13, x to the 4th plus 12. Oh, is that all in a power? No wonder that looks so weird. Sorry. Let's try that again. Great, because I really wanted to type it in again. X to the 6th plus 13, x to the 4th. That's minus. Of course it is. Doing great so far here, guys. Minus 13x to the 4th plus 12. On bottom, I've got 10x cubed. And then plus 3. Make sure you move out of that exponent. Otherwise, you do weird stuff. There's my graph. Or there's my equation. What's up? Okay. Notice that we're doing it at 5.1. And so I'm going to graph, I don't really need to graph anything for the first one. I just want to find acceleration. So what am I going to do in my calculator to find acceleration given velocity? Math 8. Math 8 is going to get me what I need. Math button. When I hit that math button, math 8 is telling me the numerical derivative. So that's what I'm going to set up. dx. Inside the parentheses, I'm going to type in my equation. My y1 goes right there. And x is going to be equal to 5.1. So I'm going to type in 5.1. I'm going to hit enter. There's my answer. How many decimals do I need to go? 3. It is always 3. If you put 2, it is going to be completely wrong. You have to put 3 decimals or it's all the way wrong. So make sure you do. 6.492 is my answer. Do not just write 6.492. This could be a free response question. And part of you getting those points is you writing what we just did. We found v prime at 5.1. Okay, or you could write a at 5.1 because they know that you know that the derivative of velocity is acceleration. But you need to have some sort of label with it. You can't just put a number and put a circle around it. You got to say what it is. Questions on A. Letter B says, find all the values of t on the interval from 0 to 2. Anytime they tell you an interval, make sure you're paying attention to that. For which the speed of the particle is 1. Speed of the particle is 1. They didn't give me an equation for speed. They gave me an equation for velocity. What do I need to do with velocity? Or how is speed related to velocity? It is the absolute value of velocity. Okay? It is 1. And it's hard to imagine that the word is gives so much importance here, but it's really important. It is 1. The speed is 1. So what does that mean about velocity? Velocity is going to be equal to what? 1 or negative 1. Because absolute value, well, what's the absolute value of absolute value of 1 is 1, And the absolute value of -1 is also 1. Either one could be true here. I need to know both. Okay, so in my calculator, I need to do this. I need to figure out when velocity is 1, because the speed could be 1, or -1, because that would also mean the speed is 1. Okay, how could I do that? How could I figure that out in my calculator here? Well, perfect. We're going to graph 1 and -1. If I want it to be, I want it is 1, that means I want it to be equal to 1. That means I just want to figure out when we get those values. Okay, so Will did a great job. He said graph 1 and -1. I'm going to change my window here a little bit just to make life easier. We said specifically that I want to be on the interval from 0 to 2. So I'm going to go make my x maximum 2 and my x minimum 0. And then hit graph. There's my graph. If you wanted to, you could zoom in a little bit more, like my y min and my y max. I'm going to make that -6 and 6. You don't have to do that, but I always like to be zoomed in a little bit more. Hit the mode button. It's supposed to be in radians. It won't affect you on this question, but yeah. I have a bet computer. Yeah, I just got a computer, so it graphs faster on mine. What's up? When I typed it in, I just typed the number. Alpha F4. Okay. Here we go. So we are trying to find those spots. So when am I equal to 1? Well, I'm equal to 1 right there. When am I equal to -1? Right there. I just got to find those values. So I'm going to go second. Calculate. What am I trying to calculate? The intersect. I'm going to number 5. So I'm going to move my cursor to where the first two lines intersect. I'm going to put it on top of each other as close as I can. I'm going to hit enter. Mine is nice because it does a color. And it says the red one. Yep, we're good. The guess. Yep. Boom. There's my answer. 3 decimals, 0.772. Then I got to find the other one. So I'm going second. Calculate. The intersect. I'm going to move my cursor down to here. First curve, I'm going to hit enter. Notice that when I hit second curve, it jumped back up to the red line. I don't want the red line. I want to know when I intersect the black line. So you got to hit the down button to get it to jump back on the black line. Now notice that I'm jumping on the black line. And that, again, it's nice to have the color calculator because it'll tell me that I'm on the black one. I hit enter again. Guess. Boom. There's my answer, 1.401. Those are my two values. Okay, a little bit different. They told me velocity. The first one was easy. We just used math 8. The second one, we wanted to know speed, which is the absolute value of velocity. And so I want to know when it was equal to 1 or -1, both the values there. Okay. Today, we are doing a free response day. So remember, half of your test on Friday is free response. Again, this test is a little bit different because free response is a lot of different things. What we did in Bell Work, technically free response. We didn't have a lot to write. Okay, it's not necessarily about always writing the right thing. It's making sure you show all your work to score all your points. Okay, and we will see that today quite a bit. Okay, so today we're kind of jumping around. We got a lot of different things. We're going to talk about differentiability. We're going to talk about chain rule. We're going to talk about motion. All of those things are important for today's lesson. Okay, making sure we understand those concepts. There's a lot of different things. You just got to pay attention and be ready. More than anything for this test, you just got to make sure you're ready for the test. Okay, the free response is not going to be exactly perfect on each one. Okay, this first question, I did it earlier today, and it's a good question. I really like it, but it's set in 1986, and they give you an absolute value, and it's not something that I necessarily want to do right this second. Okay, it's not bad. It's easy. If they give you absolute value, find the slope. Okay, it's either 1 or -1. Okay, but let's do the same question on a little bit more modern question. So let's jump to the second one. So this is from 2003. We're going to do another one of these in Bell Work tomorrow, so if it seems a little strange, we'll get better at it. It says, so suppose that the function g is defined by this equation right here. So this is g of x, where k and m are constants. If g is differentiable at 3, find the values of k and n. Okay, that's our ultimate goal here. So it says we are differentiable. In order to be differentiable, what has to be true? We got to be continuous. So we're trying to find some special values here. We've got to be continuous. This is a question that they'll ask on both free response and multiple choice. So let's do continuous first. Okay, so this is something we know. We have to be continuous. What do I need to show that this weird piecewise function is continuous? Left, middle, right. The good news here is I really just care about the left and the right because it's already equal. So we're going to do the limit as x approaches 3 from the left. So that's this equation right here. This k square root of x plus 1 needs to be equal to the limit as x approaches 3 from the right, which would be the other one, this mx plus 2. Those two equations are going to show that I'm continuous. Okay, that's what I need to do. Cool, so let's do that. What do I need to do with these equations to figure out when I'm continuous? Plug it in. We're going to plug in 3 into this equation right here. So it's going to be k of the square root of 4 is equal to m times 3 plus 2. What's square root of 4? So 2k equals 3m plus 2. Can we do any more solving there? No, I'm kind of stuck. All right, so that's as far as I can go. I did that, though. That's the continuous function. I got stuck. I can't do anything else. Fine. Okay, that's continuous. I also need to be differentiable. Tell your neighbor, what are you looking for on a continuous graph to see if you're differentiable? Or in other words, when are you not differentiable when you're continuous? Talk to each other. Show me with your hands. When is a place continuous but not differentiable? There. At a corner point. Right there. I'm continuous, but I'm not differentiable. What is true about the slope on this side and the slope on that side? They're different. If your slopes are different, then you're not going to be differentiable. Okay? So that is how we're going to decide if we're differentiable. To do continuous, we find the limits of both. To find differentiable, we are going to find the limit as x approaches 3 from the left. Try to see if that's equal to the limit as x approaches 3 from the right. But this time, instead of the values, we are looking at the derivatives. So I'm going to find g prime of x and g prime of x. I want to see if the derivatives of both equations are equal to each other. Everybody understand what we're doing here? With your neighbor, find the derivative of that first one. That's going to go right here. Remember that k in this case is a constant. It's like the number 2 or the number 4. First thing I would do is rewrite it. That would be my first thing. I would write that as k, x plus 1 to the 1/2 power. Take the derivative. Go. We're finding the derivative of this thing right here. That's this thing right here. What are you going to do there, Jesse, to find that derivative? Chain rule. Good. So what did you do? 1/2 in front, and then you still got that k out in front. What's your new exponent going to be? Negative 1/2 is my exponent. What goes inside the parentheses? X plus 1 goes inside the parentheses because we rewrite the baby, and then we multiply by the derivative of the baby. The derivative of the baby is just 1, so we don't need to multiply by anything. Good. That's the derivative of the left side. Then we got to take the derivative of the right side. So now I'm taking the derivative of this guy. What is the derivative of mx plus 2? It is m, because m is a constant. What's the derivative of 3x plus 2? The derivative of 3x plus 2 would be 3. So the derivative of mx plus 2 would be m. So this side over here is just m. It's weird, but that's what we did. We found the derivative of this guy, derivative of that guy, set them equal to each other. When do I care about this derivative? At 3. So it's 3 plus 1, which is 4. 4 to the negative 1/2 power. What's 4 to the 1/2 power? 2, because it's square root. What is the negative going to do? Flip it. This is the reciprocal. So this is 1/2 times k times 1/2 is equal to m. Or in other words, 1/4 k equals m. We plugged in 3 right there. We got 4. 4 to the 1/2, negative 1/2 power was 1/2, and then I just rewrote it. Now look what you got. You've got an equation right here. You've got an equation right there. 2 equations, 2 variables. What method did you learn in Algebra 1 to solve an equation with 2 variables? Substitution. Do substitution and finish that problem. Anybody have a good way of doing this? Aaron? Good. Okay, so we're plugging in. So he's got 2k equals 3 times 1/4 k plus 2. So we just substituted in for m. Yeah, you could write 3/4 k totally. That would be something you could do. Here would be my suggestion here. Anybody like fractions? Because I don't. I want to get rid of the fourth. So what could I do to get rid of the fourth? I could multiply everything by 4. As long as you do it to everything, you're fine. So then I get 8k equals, those 4s are going to cancel. So now it's 3k plus 8. 5k equals 8. So what's k going to be equal to? 8/5. That is my k value. Okay, then I could plug that back in to find m. While not fun, you could do it. It is 2/5. Okay, don't get distracted here at the end just because the answers were ugly. Here's what I want you to do. Differentiable, oh, that means continuous. We set the limits equal to each other when we solve. Oh, differentiable, that means the derivatives are equal to each other. I took the derivatives and set them equal to each other and solved. And then I did some work at the end. Ugly answers, sure, but you can handle that. Okay, you did substitution and elimination back in 8th grade, 9th grade. You're smart enough to do that now. Questions? I took 1/4 of 8/5. That's how I got 2/5. 1/4 of 8/5 got me 2/5. That question's good. It's a little uglier than I want it to be. The next question is the most important question of the day. Okay, if there's one question that I guarantee will be on the AP exam in some fashion, it will be a question like this one. Okay, this is from 2014. They've only done it more since then. The function p is defined by this equation. Okay, p of x equals this thing. Find the slope of the line tangent to the graph of p where x is equal to -1. What are you going to do with p if we want to know the slope of the line tangent to the graph of p? Find the derivative. We need to find p prime of x. You will score 1 point on this question if you write down what p prime of x is correctly. So they told you what p is. With your neighbor, find p prime. Go. We are finding p prime of x. To take the derivative of this thing, what rule do we need here? Chain. I've got an outside function. I've got an inside function. Okay, there are no x's being multiplied here. There is x squared minus x on the inside. That is a product rule, or I'm sorry, a chain rule question. Okay, so first thing we need to do is take the derivative of the outside. Isabella, what's the derivative of f going to get me? F prime. She took the derivative of the outside. What's going to go inside your parentheses? Good. X squared minus x. She rewrote the baby. X squared minus x times the derivative of the baby. So what did you multiply by? 2x minus 1. Good. That's our setup. But if you write your answer like this, you're going to get 0 points out of 3. Okay, because it's going to screw everything else up. Because Isabella said it correctly. We did that, and when we multiply by 2x minus 1, you got to throw it inside of parentheses. Because if you don't, you're going to screw it all up. Okay, it's got to be in parentheses. It's being multiplied together. Questions on my derivative. That's the most important part. We're trying to find the derivative, p prime, at -1. So I'm going to throw a -1 in there. All right, so everywhere I have an x, I'm going to plug in -1. And it gets a little bit rough here because there's a whole lot of parentheses. But you got to be able to do it. take a second here with your neighbor and try to simplify that down. Show me with your fingers what number is going back inside these f prime parentheses. Should get 2 because negative 1 squared is 1 minus a negative 1, so it's plus 1. Okay, cool. It's f prime at 2. Out here, it's 2 times negative 1, so that's negative 2 minus 1. Oh, that's negative 3. So I'm doing f prime of 2 of negative or times negative 3. So what I need to do next is I need to figure out what is f prime at 2. That's the mystery here. Okay, because if I know that, if I know this, then I'm done. Okay, this is the second point of this question, is finding f prime at 2. That is a graph of f. What are you looking for on that graph of f to tell you f prime? The slope. I asked this question last class, and I would say like more than half missed it. Find the slope of this graph at 2. Do that now. This is the most missed question, I would say, on Friday's test, is looking at a graph, or at least the easiest questions missed. Looking at a graph and finding slope. Show me with your fingers. What is f prime at 2? F prime at 2 should be negative 2. Okay? Just this is where I'm looking for. So it's a straight line. So I can pick the slope anywhere. So I'm going to go from this point to that point. To go from here to here, I'm going down 1, 2, 3, 4. I'm going over 1, 2. Down 4, over 2, rise over run. It is negative 4 halves, otherwise known as negative 2. That's negative 2. This is negative 3. My answer is 6. That would be the third point. You got 1 point on this question if you wrote the derivative correctly. You wrote 1 point on this paper if you wrote somewhere that f prime at 2 is negative 2, and you got another point for 6. Your work needs to be clean, like mine. Okay, it's way easier to write and way easier to give you full credit when you do that. Questions on 14 or on that one? Keep with me. Let's go to the backside. On the backside, we're talking about more with motion and using our calculator. Okay, this question was technically a non-calculator question, but we're going to use our calculator to figure it out. A particle moves along the x-axis, so velocity is given by this equation right here. All right, for that interval from 0 to 5. Find the acceleration at t equals 4. And find all the time on the interval when your particle changes directions and when does it move to the left. Okay, this is a calculator question. Could you take the derivative of this velocity equation? Sure, but don't. You get to use your calculator. Use your calculator. Okay, take a minute right now. Answer both those questions with your neighbor. Go. We type in that equation as y1. Our job is to find acceleration. What do I need to do with this velocity equation to find acceleration? Find the derivative. But this is a calculator question, so you don't actually need to find the derivative. Okay, using like by hand. We can find that derivative. We don't need to. All we got to do is find v prime at 4, otherwise known as a at 4. If you label either one, that's fine. You don't have to show what you did in your calculator. You just need to do it here because this one's pretty straightforward. What am I going to do in my calculator to find acceleration? Math 8. Math 8. I type in dx. Inside that equation, I'm going to do y1. Or you could just right there type in the natural log of t squared minus 3t plus 3 thing. X is equal to 4. Hit enter. Boom. There's my answer. 3 decimals, 0.714. That scored me my 1 point. That's possible on this question. Everybody go with the first one. Letter B. Ask me, when does this particle change directions? Notice the interval, because the interval matters. It says from 0 to 5. Okay. Let's write this down before we even look at our graph. The particle changes directions. They gave me velocity. What needs to happen with velocity for you to change directions? Velocity changes signs. If they asked me to justify this question, that is what I would state. When does it change directions? When velocity changes signs. Okay? So again, this, while it says 3 points, might not actually be worth 3 points, but writing that down is important. Velocity changes signs. We're going to hit the window button. We only care from 0 to 5 because that's what it gave to me. Hit graph. Okay, I zoomed in. If you're looking at a negative 10 to 10 window, it's probably too tight for you to be able to see it. Okay, so change your window. Even on mine here, I could zoom in even more. I could go like negative 4 to 4, and it would just give me a little bit tighter picture. Okay, the tighter it is, the better it's going to be to see it. I want to know when it changes signs. Tell me now when velocity changes signs. Boom, right there. Okay, you could find it. Second, calculate the 0. We're pretty clear as we look at that thing what it is. We go to the left, hit enter. Go to the right, hit enter. Oh yeah, it's at 1. Okay, this one's a pretty easy one. The zeros are at 1 and 2 here. They're not always going to be that clean. This one it is. Okay, so when does velocity change signs at t equals 1 and 2? Why? Because velocity is going from above the x-axis to below. It goes from positive to negative. And here it goes from negative to positive. So 1 and 2 are the 2 places I care about. I hit the window button and change my x-min and my y-min and my y-max. Just change those numbers. The second part of the question, that was the first part. The second part says, when does the particle move to the left? What needs to be true about velocity to move to the left? Velocity is negative. That's when I'm moving to the left. And so looking at that graph, when is velocity negative? From when to when? 1 to 2. 1 to 2. And anytime we talk about velocity, we're going to use brackets. If we talk about acceleration, we can use parentheses. But here we're talking about velocity. We can throw that in brackets. Questions on B? Yes, ma'am. Okay, I'll come check 1 second. Let's look at one more. Okay, 2011 question. We're going to skip part B, not because it's bad, but just because I don't want to confuse it with stuff we don't necessarily need right this second. They gave us velocity. They gave us acceleration. Your job is to decide if the speed is increasing or decreasing, and then figure out the acceleration at the time the particle changes directions. Do those 2 questions with your neighbor. So we are talking about speed of the particle increasing or decreasing. What do I want to look at if I'm talking about speed? I really want to look at velocity. So if we're talking about speed, looking at velocity is going to be helpful. Okay, so I went to y equals, I typed in that equation. I went to my window and I made it from 0 to 8 because I'm talking about 5.5 just so I could see a little bit. I zoomed in my y min and my y max a little bit. You'll get better at as you go. Okay, but there is my graph. The question is, am I speeding up or slowing down at 5.5? So I'm going to go second, calculate the value at 5.5. Okay, so right there. Okay, that's 5.5. I just put an X on my paper, so I definitely knew where it was. At that spot, thumbs up if you think you're speeding up. Thumbs down if you think you're slowing down at 5.5. Thumbs up if you think you're speeding up. Thumbs down if we're slowing down. I'm getting a little bit of both. Okay, at 5.5, we are speeding up. We are speeding up. Think about if you are driving your car. Okay, you are driving your car and you're speeding up. What is happening? That speedometer is getting further away from 0. Even if it's going negative, it's getting further away from 0. Okay, let's talk about a good explanation. Right now, all we've done is look at graphs. Okay, I'm going to teach this to you now, even though we haven't learned it before. Speeding up. To justify whether you're speeding up or slowing down, you need to look at velocity. Okay, we need to find V at 5.5. Just in general, what is the velocity going to be at 5.5? Is velocity going to be positive or negative based off of this velocity graph? Negative. I'm below the x-axis. In fact, I found it. It's this number right here. It's this negative 0.453 number. Okay, so velocity is a negative 0.453. What about acceleration at 5.5? What are you looking for on this velocity graph to talk about acceleration? The slope. right? Velocity, acceleration. Oh, that's the slope. What is true about the slope at that x value right there? It's negative. And so we could find it. I'm not even going to do that right now. I'm just going to say the acceleration is negative. Here is how we determine if we're speeding up or slowing down. We are speeding up because velocity at 5.5 and acceleration at 5.5 have the same signs. They're both negative, okay? Understand why. I'm below the x-axis and I'm going further away from it, okay? Like right here. What's true about the velocity at this spot right here? What would be true about the velocity where this little cursor is? Velocity is positive. What's true about the acceleration right there? Positive. They're both positive. Are you speeding up right there? Yeah, you're getting further away from zero. Here, you're slowing down because you're getting closer to zero. Your velocity is positive, but your slope is negative. You're getting closer to zero. Okay? That is what we're looking for. That's how we are going to define that. We'll do that later on. I'm not going to ask that specific question on this test, but we'll get to it eventually. Let's skip down to letter C. Okay? The particle changes directions exactly one time. From 0 to 6. So I got to change my window. I'm going from 0 to 6. It changes directions one time. Tell me now when I change directions. Right there. Velocity changes signs. Okay, so we got to find that spot. Second, calculate the 0. I'm on the left side. I'm going to hit enter. I'm on the right side. I'm going to hit enter. I'm going to hit enter a third time. I get 5.1955223. Is that the answer to this question? No, that's when it happens. The question is, what is the acceleration? So you can do one of two things. You can write out that whole decimal. Okay? Write out the whole thing and find the derivative at that spot. Or I do this. Remember how we did this the other day? We took that x value that I just found, and I'm going to save it as a. 5.1955. There it is. You can just write it down. If that's confusing to you, write down the decimal. I want to find acceleration. So what do I need to do with my velocity equation? Derivative. Math 8. Yes, sir. You take the x value. You just hit the x button. And then there's the store button right down there. Right here. And then go alpha A, and it'll save it for you. Okay, we're doing math 8, the numerical derivative of our equation at that value. So you can just type in that decimal if you want to. 5.195522263. Or you could just do alpha A, and it'll be a lot easier. Negative 1.587. So A at that 5.551 number is negative 1.587. Questions? We have the